So in this video we're just going to have a look at a review of some trig. So we're just going to be looking at solving equations using the cast diagram. So here's an example. So it says solve sine x is equal to half for x is between 0 and 360 degrees. So we're just going to do a review of what happened in P1 to solve these types of equations. And then we're going to try a few more examples which are going to be similar to this one, but then just changing some values and the domain of x. So just remember this angle x attached to the sine here has its domain, which should be given to you. So here x is between 0 and 360 degrees. So the process is going to be that you have to always find your reference angle before you use the cast diagram. So the first thing you want to do for your trig equation is get your trig function by itself on one side of the equation. So for example, you're either going to have sine x is equal to some value, cos x is equal to some value, or tan of x is equal to some value. So luckily in this case over here, sine x is already the subject of this equation, so we don't have to manipulate it in any way. The second thing you want to do is get your reference angle. So you're going to arc sine whatever's on the right side, or you're going to arc cos whatever is on the right side, or arc tan whatever is on the right side. And just remember that the value that you arc in with sine, cos, or tan has to be the positive value of whatever's on the right side, because this is going to get your reference angle that you're going to use in the cast diagram. And then the final step is to actually draw the cast diagram and then find your solutions for x. So we're going to use this as an example. So we already have sine x is equal to a half. So in step 1, on the right side, we already have sine by itself. So that's all good. The second step is to arc sine. So remember, arc sine is just taking sine to the other side of your equation pretty much. So the reference angle is going to be arc sine, and we always take the positive value of whatever's on the right side. So here, half is already positive, so that's all good. So arc sine of a half is 30 degrees. So that's our reference angle. So that's the angle that we're going to use to now go get our solutions in the cast diagram in step 3. So now we actually draw the cast diagram. So remember it's C-A-S-T. And we always work with the horizontal line in the cast diagram. So remember this is 0 degrees, then it goes up to 180 degrees, and it goes back to 360 degrees below here. So we look back at the equation where sine x is equal to some number. So over here sine x is equal to a half. And we just ask, is sine x equal to a positive value or a negative value? So this half over here is positive. So what you do in the cast diagram is you mark where sine is positive. So remember, the cast diagram tells you where these trig functions are positive. So every single trig function is positive in the first quadrant, where the A is. So that means sine x is positive here. And then remember, S stands for sine. This is where sine is positive, so that's correct. The T quadrant is only where tan is positive, so sine's not positive there. And the C quadrant is only where cos is positive, so sine is not positive there. So that means our solutions are only in the top 2 quadrants here. So just take note that your reference angle here, the 30 degrees, that is already in the first quadrant. So that's already a solution here. So the first solution is x is equal to 30 degrees. The second solution is in the second quadrant, or the S quadrant. So remember, your angles always start from the 0 line, and then we go anti-clockwise up until, for example, the 180 degree line. And then if you want to go back into this sine quadrant, you have to subtract an angle to go back, 180 degrees minus some angle, to work a bit backwards from that line into the sine quadrant. So in other words, to get the angle in the sine quadrant, you're working from that 180 degree line, you're going to say x is equal to the 180 degrees minus your reference angle, which is 30. And that gives you 150 degrees. So these are our two solutions for x. And you can always check if it works. If you take the 30 degrees and the 150 separately and sub them into this x at the top here where it says solve, if you say sine of x, which we'll use now as 30 degrees for example, so if you type sine of 30, you should get a half. And if you type in sine of 150, you should also get a half. So it works out. So that's the first example. So let's just solve something that's very similar. So we have sine x is equal to, but now instead of a half, let's say minus a half. For x is between 0 and 360 degrees. Okay, so we're just going to follow those steps again. We've got to make, for example, sine x equal to some value in the beginning. In other words, sine x by itself on one side of the equation, which is already happening over here, so that step is done. Next thing you want to do is find your reference angle by arc sining the value on the right side of the equation. But remember, the value that you are arc signing must be the positive value. And then the third step is to use your cast diagram to solve for your x values. So the second step over here, to get your reference angle, you're going to arc sine, but now you're taking the positive value of what's on the right side, so you ignore the minus for now, which is 30 degrees. So now that you've got your reference angle, now we're going to use our cast diagram to get our solutions for x. So we draw our cast diagram, so C-A-S-T. Now we look back at the part of the question where you have sine x by itself, where it's equal to some value, which is the original equation over here. And just take note that sine x is equal to negative a half. So sine is negative here. It's negative a half. So in the cast diagram, we tick where sine is negative. And sine is negative in the t quadrant, because that's only where tan is positive. And sine is negative in the c quadrant, because that's only where cos is positive. So I'm going to mark that's a 0 line. This is 180, 360. So now we're going to use this cast diagram to get our solutions. So remember, the angles, you always start from the 0 line and you rotate anti-clockwise. So you'll get to the 180 degree line, but then you need to go further into the t quadrant. So when you get to 180 degrees, you actually have to add on another angle to go a little bit further into the tan quadrant. So the first solution here will be x is equal to, so we'll take the 180 degrees, and the angle we're going to add on to get it into the tan quadrant is our reference angle, the 30 degrees. So here x is equal to 210 degrees. And then lastly, to get the solution in the c quadrant, so we'd go a little bit further all the way to the 360 degree line. But then what we have to do is subtract some angle to go a little bit back into that cos quadrant. So we're going to take 360 degrees minus our reference angle to get us back into the c quadrant. So x is equal to 360 minus the reference angle, and our answer is 330 degrees. So if you want to see if these two solutions work, all you do is substitute them into the x in the equation here. So if you go sine of 210, you should get minus a half. Or if you go sine of 330, you should also get minus a half.